Hi and welcome to another tutorial video. In this tutorial video what I'm going to be discussing is Karnaugh Maps. And what a Karnaugh map is a graphical method of simplifying Boolean expressions, and some people might find this method easier than simplifying a expression using Boolean algebra. But if you've been asked in an exam to use Boolean algebra, then you should use Boolean algebra, and then you could also use a Karnaugh map to check your answer. Okay, so this method works especially well if you've been given a truth table and want to directly find the minimal Boolean expression. But I'm going to show you how you can use it for any Boolean expression. Okay, so there's really 4 stages to using a Karnaugh map. First of all, you've got to construct a truth table, that is if you haven't already got one. Then you've got to draw the Karnaugh map. Then you've got to use the truth table to fill out the Karnaugh map. And then you've got to find groups in the Karnaugh map and generate a simplified expression. And I'm going to go through these stages with some examples. So this example is one from my Boolean algebra video, and I'm going to show you how to use the Karnaugh map method to simplify the expression. So first of all, we're going to construct a truth table for this expression. So I've got my A input, my B input, and my output. And what I can do is just plug in the values in my truth table for on each row into my unsimplified expression to get the output column. So we've got 0 and 0 ANDed with 0 or 0, which is just going to be 0. We've got 1 ANDed with 0, ANDed with 1 or 0, which is going to be 1 ANDed with 0, which is going to be 0. We've then got 0 ANDed with 1, which is ANDed with 0 or 1, which effectively is 0 and 1, which is 0. And then finally we've got 1 ANDed with 1, and that's ANDed with 1 or 1, which is 1 ANDed with 1, which gives us 1. And you can probably see there that what our simplified expression is going to be just from the truth table, and that will be the case with some expressions, and you can use a truth table to simplify Boolean expressions in that way. But for some more complicated Boolean expressions, it will be difficult to see just from the truth table what the simplified expression is, and it will be a much more long-winded way of doing it than using a Karnaugh map. Okay, so that's our truth table. The next stage is to draw our Karnaugh map. And first of all, I draw 2 axes. So I draw a line going horizontally across the top there, and a line going vertically down like that, and a line, a diagonal line here, and these are my axes, if you like, of my Karnaugh map. What I then do is put one of my inputs above this diagonal line here, and one of the inputs below the diagonal line there. And then what I'm going to do is use what's called a grey code to label the axes, and you'll need to use a grey code where the number of bits in the grey code is equal to the number of inputs that you have on that axis. And I'll show you how you can have multiple inputs on an axis in a minute, in another example. So, because I've only got one input on each axis at the moment, I just use a 1-bit grey code. So that will look something like this: 0, 1, and 0, 1. And if you're not sure about how to generate a grey code, I'd recommend you watch my video on generating grey codes, and you should get the idea from that. Okay, so now that we've got our Karnaugh map, what we need to do is look at each cell of the Karnaugh map and use our truth table to fill it in. And the way we do that is we look at each axis from each cell. So say I'm looking at this cell here, I look on the A axis and the A input is a 0, and I look on the B axis and the B input is a 0. So I look in my truth table to see where both A and B are 0, and the output is 0, so I write a 0 in here. What I then do is do the same thing for this cell. So my A input is 1 and my B input is 0. So in my truth table when A is 1 and B is 0, the output is 0, so put a 0 in here. And the same goes for this cell down here. A is 0 and B is 1, and when A is 0 and B is 1 in my truth table, the output is 0, and then in the last cell the output is going to be 1. Then what we need to do is move on to finding groups in our Karnaugh map and generate a simplified expression. And what I mean by groups is groups of 1. So the only group of 1 we've got in our Karnaugh map at this stage is this one on its own here, and that counts as a group. A group, the size of a group can be any power of 2, so 1, 2, 4, 8, 16, and so on. And we then take these groups and get our simplified Boolean expression. So this is our only group here. And what we have to do to get a bit of our final simplified Boolean expression from a group is look at, on the axes of the Karnaugh map, what is common about all the cells in the group. So because in this group there's only one cell, we can see that what is common about both of the axes is that A and B are both 1. And that means that, and because A and B are both 1, the inputs are not inverted, and we simply AND those inputs that are common together to get our simplified expression. And that the Karnaugh map has shown us there that the simplified expression is A and B. And you can see from our truth table that that's the case, because this is a relatively simple example. But I'm going to move on now to doing some more complex examples to show you how Karnaugh maps can be really useful for simplifying those more complex Boolean expressions. Okay, so here's a slightly more complex Boolean expression that we want to simplify. So let's start by filling out our truth table for this more complex Boolean expression. So for the first row, not A is going to be a 1 and not B is going to be a 1, and if we AND them together that gives us a 1. Not A is going to be a 1 and B is just a 0, so if we AND those together that's a 0, and the same is going to be true for that, and that's going to be a 0. So we OR all of those together, we're going to get 1. Then if we do the same for this row, we're going to get 0 or 1. That's going to give us a 1. And if we do the same for this row, we're going to get 0 or 1 or 0, which is going to give us a 1. And then if we do the same for this final row, we're going to get 0 or 0 or 0, which is going to give us a 0. So that's our truth table, and it might also be obvious in this example from the truth table what the final Boolean expression is going to end up being, but nevertheless I'm going to go through the Karnaugh map method. So next we draw our Karnaugh map, and because we've only got one input on each axis, we'll use a 1-bit grey code to label the axes. Then we look at when A is 0 and B is 0 in our truth table. The output is a 1. When A is 0 and B is 1 in our truth table, the output is a 1. When A is 1 and B is 0 in our truth table, the output is a 1. And when they're both 1, the output is a 0. Now I've got some slightly more complicated groups in our Karnaugh map, and one thing to note is that you might look at this and you might do something like this, and that's not valid for a number of reasons. One is that you can't group things diagonally, you can't group ones diagonally, and the other reason is that, as I mentioned in the previous part of the video, the the size of a group has to be a power of 2. So how can we group that in a valid way then? Well, we can group these two ones together, and we can group these two ones together because a 1 can be in multiple groups. So then what we do is we take a look at the horizontal group and see what is common about the cells in that group. Well, in the horizontal group, in both cells, the B input is a 0. And that means that in our expression we're going to have not B. And in the vertical column, the A input is always in the vertical group. The A input is always a 0, and that means we're going to have not A in our expression. And then if you get more than one group, what you do in the to make up your simplified Boolean expression is you all the Boolean expressions you've got from each group together to get your final simplified Boolean expression. And you may notice that if you wanted to write this in a different form, you could use De Morgan's law to write it like that. So A and not A and B. And that's probably what you would get if you just derived the answer directly from the truth table. Okay, so final example then, a bit more complicated, and this should show you how Karnaugh Maps can be really quite useful, because as you can imagine, the Boolean algebra simplification of this is going to be relatively complicated. So first of all then, what we do is construct our truth table. Looking at my expression then, I can tell that the first part is going to be, for the first row, is going to be 1 or 0 or 0 or 0, which is going to give us 1. Then we're going to get, from this row, 0 or 0 or 0 or 0, which is going to give us 0. And for this row we're going to get 0 or 0 or 0 or 0, which is going to give us 0. For this row we're going to get the same 0 or 0 or 0 or 0, which is going to give us 0. And then for this row we're going to get 0 or 1 or 0 or 0, which is going to give us a 1. And for this row we're going to get 0 or 0 or 1 or 0, which is going to give us a 1. And then for this row we're going to get 0 or 0 or 0 or 0, which is going to give us 0. And for this row, for the final row, we're going to get 0 or 0 or 0 or 1, which is going to give us a 1. Okay, so that's my truth table. I'm just going to type this up a bit so that we have room to draw the Karnaugh map. You can see from this example that the truth table doesn't always make it immediately obvious what the simplified Boolean expression is, and this is where the Karnaugh map comes in real handy. So when we've got more than 2 inputs, what we can do with our Karnaugh map is put 2 inputs on one axis. So in this example I'm going to put A and B on this axis and C on this axis. And because on this axis I've got 1 input, I just need a 1-bit grey code. But on this axis I've got 2 inputs, so I'm going to need to write down a 2-bit grey code. So I've got my Karnaugh map there. Now what I do is simply use the truth table to fill it out. And sometimes I find it easier to just look at the ones and fill in that, and then just fill in all of the rest of the Karnaugh map as zeros, and you can do it whichever way you want as long as it's correct. So there's a 1 when all 3 inputs are 0, so there's a 1 here. There's a 1 when A is 0 but B and C are 1, so that's going to be this one here. There's a 1 when A and B are 1 but C is 0, so it's going to be this one here. And there's a 1 when all 3 inputs are 1, and that's this one here. So we can take all of the other as 0. And then what we do is identify some groups. So we can see that there's a group of 2 here. There's also a vertical group of 2 here. And there's a group of 1 over here. And it is worth noting that if, for example, this cell here was a 1, I could group this cell here with this cell here by wrapping around the table, and that is allowed. So taking this group then, for instance, what is common about the inputs for both of these cells? Well, B is a 1 for both of the cells, and C is a 1 for both of the cells. So our Boolean expression from this group is going to be B and C. From the vertical group, A is 1 for both of the cells, and B is 1 from both of the cells. So our Boolean expression from this group is going to be A and B. And then for this group on its own here, What's common is that all of the inputs are zeros, so our Boolean expression from that group is going to be not A and not B and not C. Then to get our final simplified Boolean expression, all we do is OR them together. So not A and not B and not C, or A and B, or B and C is the minimal form of this expression up here. Okay, so that's how you can use a Karnaugh map to simplify Boolean expressions. Hope you found this tutorial video useful, and thanks for watching.